today we are going to be talking about Jetpack Compose. So if you haven't heard about Jetpack Compose before, it is the new way of doing UI developed by Google. So Google has developed Jetpack Compose a couple of years ago. It was in beta and then it was fully released as a stable version, and Google is recommending all Android native developers to move into Jetpack Compose. Why should we use Jetpack Compose? So Jetpack Compose simplifies and accelerates the UI, brings the application to life with less codes, powerful tools, and initiative Kotlin APIs. And as we all know also, or if you aren't familiar with this, also Google moved Android from Java to Kotlin. It still supports Java, but at the moment it is more recommended to use Kotlin because it's the new language. So also Jetpack Compose builds the UI in a way of like objects. So they're like, let's assume we have, for example, a loader. And this loader is a custom loader, like Lottie, for example. And this loader is going to be visible in every single page of the application. Rather than having this loader be included in every single page or having to build it dynamically in a base activity, we build the loader as a class using UI, and we just call the composable widget. This simplifies libraries, reusability of codes in UI. And it also saves memory, which we're going to see in a few. We're going to do a live coding session. We're going to see how Jetpack Compose actually helps us in saving memory. Sorry. How does Compose work? Compose works usually by observing states. If you guys are familiar with MVVM, we used to observe live data. This is the architecture that also Google implemented a few years ago, and it's now recommended to be used. So MVVM is when we save a variable inside the view model, and the view communicates with the view model, and the view model communicates with the repository, the model, the data. So that's the word of MVVM. So similar to that concept, this is how Jetpack Compose works. So the Compose observes the changes to the state, and it modifies the UI based on the change of that state, based on the event. So the event is going to dispatch the update state, and the update state is going to change the display in the UI. Okay, so now we are going to move to a live coding session. Okay, just let me see how to share my screen over there. Give me a sec. Okay, there we go. Okay, I'm also gonna. So this is the composable layout. As we could see, there is main activity. Oh, sorry. First, if you want to create a composable activity, just go into new. Compose, new empty compose activity. That's it. Or if you want to create a new project, you can go new project, empty compose activity, and you're going to be seeing something like this without the commented code that I have already on my screen. Okay. So now we're going to have this is the greeting. It's Android, but as we could see here, it's hello testing. So why is it hello testing? Because I'm using the preview. The default preview is just a way that Google gave us. Rather than every time running the application, we just have a sample display of what we're going to see on the application over here. So I have the word testing. If I change it into test, for example, it's going to automatically change over here into test. This is the default preview. But if I run my application, I'm going to try to run it. Just give me a second. Okay. Let's see. I'm not sure. You guys can't see my screen. Okay, just give me a second to show you my screen. So now you're able to see Hello Android. The reason we're seeing Hello Android rather than test is because when we are calling the function inside the Jetpack Compose, we are calling it greeting and we're giving it Android. Let me try to... Okay, so far so good. Now I'm going to split only to the code base. And we are going to implement a simple counter just to display how the states work using Jetpack Compose. I already have those codes pre-coded just to save time. Maybe we could go into MVI after we're done with this, if we had time. So I'm going to comment this default code and uncomment this. So what I did over here is just call a water counter, which is a composable function. Ideally, this function should be present in a file composable on its own, so that for reusability reason and for this page to be more readable. And we're just going to run it. So we're supposed to see on the screen just a text that's going to display you've had 0 glasses. That's exactly what we're gonna be seeing. And also I want to point out that here in the default preview, we are still seeing hello test, because over here I did not change it. Okay, now let me share again my screen. Sorry, we're gonna have to keep bumping from the code to the emulator. Okay, so it's you've had 0 glasses. That's basically it. So if we go back to the code, okay, we are going now to implement a counter, a plus counter, that's it. So over here we have var count equals to 0. We're just displaying the text, and we have a button. The onClick function is count plus plus. Simple enough. Okay, so that's all that we're doing over here, and this should not be any problem. And I'm going to run it. Okay. Okay. So now I'm going to be clicking the add one. So I'm actually clicking it, as you can see on the screen, but nothing is changing. And I'm going to paste the code over here that we just wrote. I'm going to paste it, and I'm going to tell you exactly what is wrong over here. So what we did is we actually had a var count equal to 0, and we're having count plus plus. But the problem with this is that every time I am clicking on the button and the count plus plus, it is actually reinitializing var count equals to 0. So technically speaking, the state is never changing. It's always 0. So now we're going to see how we are going to solve this, or attempt to solve it. Since we said we're going to be working with states, and we said that states resemble live data, MVVM, so we're going to be working with immutable states, because they're going to be changing. Essentially, everything that's a mutable state is any variable in the code that is going to change over any point in time. Think of it as a display of loader, display loading, success, error. So this is a state that has to change over time. So that's initially it. I'm just going to import those. And I'm going to run the app again. And I'm going to paste the code over here. I just added the mutable state of the integer. That's all I did. And now I'm running the code again. And as we can see, nothing's changed. Now I'm going to click on the button, and still there is no zeros. The counter is not changing, because having the state as immutable does not actually have Compose dispose the event. It's just tracking it. It's not remembering its state. So what we need to do is add remember. I'm gonna show you what I did. Just give me a minute. So this is exactly what I did. And I'm going to import it because it's a function done already by Compose. Okay. So usually remember and immutable states, technically speaking, they're always bundled together so that the Compose always remembers the previous state so that it can dispose an event of the newer state. So they're technically speaking always together. And now we're gonna rerun the application. And now I promise you it's going to work. Should work. And as you can see, okay, I said this should work, but it did not work. Just give me a second, it did not run well. Okay, and now as we can see, you can't see that it's working. Just give me okay, here it is. Now as you can see, the counter is working correctly. Now I want to mention over here that remember, I'm going to post the code also. So the last code that I'm going to be posting is the correct way of doing the mutable states. So the remember over here is not going to work if we have configuration changes. So if I auto-rotate my phone, it is going to automatically come back to 0. There is a function in Compose that's gonna save the state throughout the configuration changes, but we're not gonna go through it, but I thought I should mention it. Okay. So technically speaking, this is the beauty of state in Compose. So what's happening over here? So in this function, Compose is remembering the state of the initial value and is changing it when there is a need to change. And the beauty of this is that, well, now we only have one function, but imagine if we have a button, a list, counter, and a few other things. So Compose at the moment is only gonna redisplay the text. It's gonna change the UI only of the text, which is a huge memory consumption. Rather than redoing the whole UI over and over again, it's just changing the value of the text. And this is helping us a lot. And if we have the water counter in a different screen, we would be able to call this from anywhere inside the application by simply just adding it over here. And I wanted to note something that in Compose, here I'm using a column because I want the values, the UIs displayed vertically. However, if I wanted them to be displayed horizontally, I would use a row. And if I wanted them both horizontally and vertically, something like a constraint layout, I should be using a box. So far, concerning what we've covered for the time being, does anybody have any questions? Oh, I'm sorry, I didn't realize my cat was behind me. Okay. Okay, I guess we can move on to something that's a bit more architectural. Okay, so for the next part of our session, I'm going to talk briefly about Compose with... oh, no, this is native Android Kotlin. Not JavaScript. No worries. So for the next part of our session, we are going to be talking briefly about the new architectures that are booming nowadays. So we have Jetpack Compose with MVVM, which is the initial architecture that is recommended by Google. And there is a new architecture that developers are currently working with, and it's called MVI. So MVI is based on model view intent, and the intent is not the normal intent that we use in Android Studio. It's not going from one activity to another. No, that's not it. The intent is actually the intent of an action. For example, the intent of clicking a button, like we have here in the counter, the intent of showing a loader, and etc. So it's like intentions, if you want. if you want to say. So what happens here in the model view intent is actually the intent and the view are coupled in a way or another together. And any change in the intent would lead to a change in the view. And this happens by the state. So the state, whenever it's changing, is gonna change the intent. And the view would be observing the intent, and the intent would automatically change. Personally speaking, and this is just a personal opinion, I've tried the model view intent and I've tried the MVVM with Jetpack Compose, and I highly recommend Jetpack Compose for a couple of reasons. One of them is the model view intent contains so many classes. If you want, I could show you a code with, I'm going to show you one code with the model view intent. Just give me a minute to run the application. Okay, so this is actually a code that's written using MVI. It's just a simple loader, and I'm just showing a loader based on changes. So this is Jetpack Compose that's showing a Lottie animation code, fill maximum width, fill maximum height. I'm giving it a background color. Nothing very fancy over here happening. So this is the base Compose view model. Because as I said, intent kind of use MVVM, but it observes intent rather than observing states. And we are using flows, if you're familiar with them. And we're using channels. So we're sending the intent through channels. Okay, just let me see, where are we? Okay, over here. So our splash view model, because what I'm doing over here is that I'm showing in the splash activity, I'm showing the splash screen, which is a display of the loader actually. So this is the composable splash screen, and I'm telling it that if the intent of the splash view state was a loading, display a loader, else just display an image. That's it. And I'm changing the intent manually over here. So here I'm just telling it what is the state of it. I'm telling it its state. So we have 3 states, which is empty, loading, and error. So loading is just going to display the loader. Other than that, it's just going to display an image. But we have all of those classes over here just so that we could do a simple loader. So every single intent is going to require at least 2 or 3 classes. So if we have a huge application that's going to, let's say, work with 10 buttons, we're going to at least have around 30 classes. So this is my personal opinion on MVI. MVVM is easier to write, cleaner code. Like you could see, you're technically even not really doing MVVM because you are observing the state using live data rather than observing the live data itself, but it's still way cleaner, easier to test. And for those of you who are crazy about unit testing or who do unit testing, which is, by the way, very highly recommended and everybody should be doing it, it's also better to use MVVM with Jetpack Compose rather than using MVI with Jetpack Compose. So for up till now, does anybody have any question about the architecture, like my personal opinion about an architecture, like why are we using MVVM with Jetpack Compose rather than MVI with Jetpack Compose? Okay, I think everything is perfectly clear. Then let me reopen the application and we could talk a bit about the libraries, the themes in Jetpack Compose, everything that's actually completely new in this part. So now over here we have the UI theme. So before, if you're familiar with Android or if you remember, we had this REST folder the values and everything actually was here. But now with Jetpack Compose, everything is in classes. The themes, the type which is the font actually, color, everything here is in separate classes and it's in a package. This is also easier to maintain rather than having a completely separate package. So this is also one of the things that are considered a huge change in Jetpack Compose. To add Jetpack Compose to our application, and as I said, it is a stable version, and people should be taking advantage of the Kotlin delegates inside Jetpack Compose. So we are having the Compose UI, the Compose material, and the tooling preview, which is needed to just preview whatever we are previewing over here in this part, so that we do not run the application every time we need to display something over here. So even over here, as I said, it's showing greeting because that is what I told it to show. If I refresh it, it's gonna take a while to refresh. Yeah, of course you need a very powerful laptop to work with the Compose. Well, to work with Android Studio to begin with, not only Compose. Okay, so it's rendering the view and here it is. I'm just going to minimize it. So this is our typical default preview. So I did not need to run the application to see the preview of this. And this actually helps a lot. So this is why we have that default preview. Lifecycle, it's because we are working, well, we should be working with MVVM, regardless whether it's MVI or MVVM, we are working with view models, so we need the life cycle because the view models are life cycle aware. Activity compose, because we are extending a component activity, which is the new activity that uses Jetpack Compose. UI tooling for the modifier, the padding, the box, the column, everything. So this is, for example, if I want to use a row instead, and we can refresh. And here we have it. I'm just going to take it back into a column because it looks better this way. Okay. Okay. And now that we have that covered, just let me check if there's anything that I want to... Yeah, so I just want to add about something about the remember, that it is stored in the composition and kept across 3 compositions. Okay, so this is something very important because, as I said, upon recomposition, we need the remember state to remember the state. And that is actually a wrap-up of our sessions. I expected more questions, honestly, but I am going to drop down my LinkedIn. And please feel free to connect. And if you have any questions, anybody, if you would like to continue discussing more Jetpack Compose states, there's also something that's called state hoisting. I could go into it, but I felt like it's an advanced topic, but for state hosting, we technically are just separating the views, because if a composable is holding the remember state on its own, along with everything else, it becomes harder to test because they're coupled together. So with state hosting, what we actually do is we separate the composable function into two functions. One of them is just going to be holding the state, and the other is going to be holding the rest of the UI, which is the text and the button. And we are going to pass the value of the variable from the first composable function into the second composable function. And that's how that leads to state hoisting, which is a very important topic that I also advise you to read on. So I'm just going to drop it down over here, state hoisting and Jetpack Compose, because it helps in testing and it helps to maintain a stateless composable widget and a stateful. And the composable widget that has a state, it's called a stateful composable widget. Okay, so anything else? If anyone would like to add anything, feel free to drop it down right now. We still have like around 10 minutes for our session to end. So anything, does anybody like to add anything right now? Okay, I guess we are done for today. I'm so happy that you were part of this session. And as I said, please feel free to Thank you. And as I said, feel free to connect with me on LinkedIn, and we could continue this in private. Okay. Have a good day, everybody. Bye-bye.